Okay, these are the notes for section 4.5, other methods of proving triangles congruent. Now in class, you were told to go through a couple GeoGebra explorations, and we didn't really talk about angle side, but we talked about hypotenuse leg. Angle side is a theorem. It kind of follows from angle side angle. If you can prove two angles of one triangle are congruent to two angles of another triangle, then obviously their third angles are going to be congruent as well. So angle side and angle side angle, you just kind of have to pay attention as to where the placement of that side is. The hypotenuse leg theorem, when it goes through, actually kind of looks like the SSA that we already talked about does not work. But hopefully in the exploration you saw why it works in a right triangle. And again, we don't call it SSA, we call it hypotenuse leg. So in hypotenuse leg, first you must prove it's a right triangle. I'm going to show you where that comes up in a later proof, but you need to make sure it's a right triangle. Then you can show that the hypotenuses are congruent and that one of the legs is congruent. Now, right triangles can be proven congruent with SSS, SAS, ASA, AAS. They have all those other ones can still prove two right triangles are congruent. It's just with right triangles, you now have a fifth option of hypotenuse leg as another way to prove triangles congruent. So here we have a proof. And what I would like you to do is to please try this proof yourself. So push pause, try it yourself, come back, and we'll check your answers. So please push pause now. Okay, so we have some answers here. The first thing I did was the given, so I'm going to mark that on my diagram. I have angle A congruent to angle D, angle O congruent to angle U, and AO congruent to DU. So from there, and again, when you mark your diagram, you'll see it a little better. I can call triangle AOC, so all the way around here, and say that is congruent to triangle DUB by ASA. And I outline them so you could kind of see the triangles I'm talking about since they overlap. Once I have that these two triangles are congruent by ASA, again, notice where the angles I said were in the proof and the location of that side. That's why I said ASA. I can prove angle 1 is congruent to angle 2 by CPCTC. And once I have that those two angles are congruent, if I focus on this small triangle right here, I can use ITT to prove that TB is congruent to TC. In our next example, we have another set of triangles. And again, what I would like you to do is try to work through this yourself. So push pause now, work through the best you can, and then we'll come back and check your answers. So please push pause now. All right, so here I have some answers. Again, I'm going to start with what I know. I was told XA is congruent to XB, and that XY is perpendicular to AB. Now I'm going to be careful not to mark that right away because I may need to say something about that later on. So XY is equal to XY. I apologize that these don't have the congruent symbols in them. That's kind of hard for me to make when I'm typing these up. So I went XY is equal to XY by reflexive. Now, since these are perpendicular, you could have proved angle 3 is congruent to angle 4 by saying if lines are perpendicular, then they form congruent adjacent angles. The reason I did not go in that direction is I saw where the location of those angles were. Then I'll have SSA. And that's not really going to help me out. That doesn't prove two triangles are congruent. So instead, I'm going to say that angle 3 and angle 4 equal 90 degrees. And I know that because that's the definition of perpendicular lines. Since I said they were perpendicular, the angles must equal 90. From there, I can prove that triangle AXY and BXY are right triangles by the definition of a right triangle. I've proven there are right angles in there. Then I can prove the triangle is congruent by HL. And then I can prove angle 1 is congruent to angle 2 by CPCTC. Now, there are 2 points in here that are very important. If you are going to use HL you have got to say, or somewhere above it, that there were right triangles. Most popular way to show that is the definition of right triangles. Sometimes they'll give it to you and say these triangles are right triangles. Usually not. You need to have this step if you are going to say HL. That is very important. And if I'm going to say they're right triangles, I better have a statement above that where I showed that there were 90-degree angles in there. Again, sometimes that is in the given. It might say angle 3 and angle 4 equal 90. And then you wouldn't, that statement of 90 degrees is already there. But steps 3 and 4 are the most commonly forgotten mistakes when we do this type of proof. If you are using HL, you must state beforehand that you have right triangles, because HL only works in right triangles. That's why that is an important step. If you were going to say there are right triangles, you better have shown that there is a right angle or an angle measure of 90 degrees in those triangles. So that is the end. Again, we've just gone through 2 additional theorems that prove triangles are congruent.